Okay, today is the 18th of October 2023, and I'd like us to look at volume of some shapes. Okay, before I start, thank you to everyone who has been watching our videos. Okay, please subscribe, share, like, and follow us. Okay, I'll really appreciate that. And if the account is not yours, ask for permission before you do that. Thank you very much. I normally write, please follow my notes / scripts. Okay, so this is maths. Okay, at times you need to be following it. As much as I can say, the notes are accurate. So for instance, this is 140.44. So if you hear 120.4, okay, the note is the accurate one. So follow the notes, okay? Because there's a reason why it's 44, okay? Don't just assume that this is what I heard, so that's what I'm going to follow. So you should be looking at the notes, okay, and following my explanation. Okay, beware of scammers. Okay, that's all I'll say about that. Beware of them. Okay, thank you very much. Recap. Last video, last one, the one we just did, we look at the cylinder. Okay, we found the surface area and the volume of the cylinder, and I showed you an example, and then I pulled the cylinder apart, okay, and I showed you how you can even solve it without even knowing the formula, and then I deduce the formula for you, okay. That is what we did, okay. And then I asked you to update your flashcard. So this is the area. You can use this one, the surface area of the cylinder. This is pi, okay. This is pi, okay. You can use the surface area, this formula or that formula, okay, and which one is easy for you to learn, so you can use any of them. The reason is, if you put it on your flashcard and you solve more questions on under this topic, then when it comes in the exam, you would easily remember the formula to use it, okay. Now for your recap, watch last video, okay. We have a lot to do today, so I won't be able to bring it an example. Just watch last video as your recap. Now the starter: share a bag of 632 sweets in the ratio of 2:3:4. Okay, so this is another ratio question. Now the total is 2 add 3 add 4, which is 9. So to get 2 portions of this is 2 out of 9 times 632. And we get, if you do it correctly on the calculator, you have 140.44. Okay, but these are whole sweets. You can't have 140.44 sweets. So the 2 portion to the nearest whole number will be 140 sweets. Okay. Now, the 3 portion, if you do it correctly on the calculator, you should get 210.67. To the nearest whole number will be 211 sweets. Okay, as you can have 210.67 sweets. So you run off to the nearest whole number. Okay. 4/9 times 3, 632. If you do it correctly on the calculator, first I'll do 4 times 632 and divide by 9. So if you do it on the calculator, you have 280.88. Okay. Now, to the nearest whole number will be 281 sweets. So in the ratio of 2 is to 3 is to 4 is 140 is to sweets to 211 sweets to 281 sweets. Okay, you should leave your answer as whole numbers. Okay, you wouldn't want somebody giving you 0.88 sweets. Okay, so you have to give it as the nearest whole number, even though they haven't told you. Okay, so that is our starter for today. Now let's see what we want to do today. We want to look at the volume of some complex shapes. So we know how to find the volume of a triangular prism. So you find basically the area of the triangle and multiply by the length of the prism. So for the first example here I have for you, this is a prism. It's like 3 triangles, 3 same triangles together. Okay, so you have the length is from there to there. That is the length of the prism, but it has 1, 2, 3, 4, 5, 6, 7 sides, and this size are 3 similar triangles. Okay, now we need to find the volume of this shape here. Okay, this prism here. Okay, you need to find the area of this triangular bit 1, 2, 3. Okay, now because they are similar, we'll find the area of the first triangle and multiply by 3. After we've done that, the length of the whole prism is 11 centimeters. Then we'll use that to multiply, and then we have our volume. Okay, today we are looking only at volume. Okay, because if you had just one prism, you can do that. Okay, but some people immediately they see 2 or 3 prisms together and they ask them to find the volume. They ask them to find the volume. They don't want to know. But this is a simple question, okay, which you can easily do just by applying what you already know. You shouldn't be intimidated by the figure. Okay, so the 3 triangles have the same base and perpendicular height. Okay, even though it's not to scale, look at it. Same base and perpendicular height. Okay, the perpendicular height was labeled here. It wasn't labeled here. okay, but it's the same, okay, and from here to there is 12. So 12 divided by 3 is 4. So the base of one triangle is 4. The perpendicular height is 6. So you can find the area of one of the triangle and multiply by 3. Okay. So to find the area, the volume is the area of the 3 triangles times the length of the prism. If you look at it, the length of the prism from the top here to there is 11 centimeters. All your units are in centimeters, so your volume will be in centimeter cube. Okay, so even though it's a complex shape, again, okay, to emphasize that you know everything to answer this question here. Okay, you know everything. Okay, so the volume of the area of the triangle is half base times height. You know this formula. Okay, now your base here, the whole thing, 3 triangle is 12. So if you divide by 3, the base of one triangle is what? 12. So no, the base of one triangle is 4. Okay, because the 3 of them is 12. So 12 divided by 3 is 4 centimeters. Okay, so half times 4 centimeters times 6 centimeters, which is the height. The height has been given there. They could have given it to you here or there, but they gave it to you here. So you have to look for it, okay, in the diagram. Now, if you do that correctly on the calculator, or you do it mentally, it is 4 times 6, which is 24, divided by 2, which is 12 centimeters squared. It's area, so it's centimeters squared. Now, we found the area of the first triangle. So to find the area of the 3 of them, we multiply by 3. So 3 times area of the triangle. Okay, so we have the 12 here. So 12 centimeters squared times 3 is 36 centimeters squared. So we found the area of this side here. There. Okay, now to find the volume, we multiply by the length, which is 11 centimeters. So now that we have 36 centimeters squared, we go ahead and find the volume of the shape, which is the area of the 3 triangles times the length of the shape. So 36 centimeters squared times 11 centimeters. When you do it correctly on the calculator, you have 396, and then the unit of volume is centimeter cube, because they've given us all the readings in centimeters. So the volume of this shape here, the volume, okay, is 396 centimeter cube. Okay, so that is the first shape. Look at the shape again. People see this in an SR room and it's like, what is this? Please don't get intimidated by the picture. All I used here is the area of a triangle, which you know from school. So I found the area, multiplied by 3 and divided by the length. Okay. Now let's look at the second example I have for you today. So this is, we want to find the volume of the shape below. Look at the shape again. Okay, it looks like 2 cylinders put together. okay, or two pipes put together, similar cylinders, this radius are the same. Okay, I was just giving one radius, but I in the question it says the radius are the same. Okay, now the length is 30 centimeters here. So what I need to do is I'll find the area of one of the circular bay, okay, and then use that, multiply by 2 because I have two cylinders here, okay, and then multiply again by the length of the cylinder, and that will give me the volume. At times you might be lucky, they might bring a shape and give you the area of the side. Okay, in that case you just multiply by the length and then you've got your volume. Okay, but if they don't do that and they even give you a picture like this, okay, mine is big because I wanted you to see the expanded version of it. Okay, but look at it, it's two cylinders. Yesterday we look at the cylinder and we look at the surface area, how to work it out, and then without the formula, and then the end I showed you how the formula we use the formula to solve, and then I deduce the formula for you. Okay, but now you have these two cylinders here. Okay, they might not tell you, but you should be able to figure it out. Okay, so I'll find the area of the circle, multiply by 2, and multiply again and double it, that is multiply by 2, and then multiply it again by the length of the shape. If you can't see that this is two cylinders, then you will not be able to solve it. Okay, so again, a picture like this is supposed to intimidate you, but actually you know everything to solve it. So it appears like two cylinders combined. So we find the area of one circle, which is pi r squared. Even from primary school, you know that the area of the circle is pi r squared. Or year 7, year 8, you should know that. Okay. So the area of the circle is pi. I showed you in one of the videos how to find pi on your calculator, and I assume you have started using your calculator. So pi r is the radius. The radius is 16 centimeters. All our units are in centimeters, so our answer will be cubic centimeter cube if we find the volume. Okay, so now the area is pi r squared. Okay, now if you do this correctly, if you square 16 and multiply by pi, you should get 804.352. okay, it's the area, so the answer should be in centimeter cube. Okay, now they said we should leave our answer to the nearest whole number, but because I haven't finished yet, I'm going to continue because this is not my final answer. Now, so two circles here. Okay, so I'm going to multiply the first circle by 2. So if I multiply this area of the first circle by 2, I have 1608.704, okay, centimeter squared, because this is the area of the two circular bits. Now the length of the cylinder is from here to here, and we've been given as 30 centimeters. So to find the volume, now that I know the area of the two circle on top of the shape, okay, I'm going to multiply by 30 centimeters. If you do that again on the calculator properly, you should get 48,261.12 centimeter cube. So the volume of this shape here, okay, the volume of this shape here is 48,261.12, but they said we should leave our answer to the nearest whole number. So the volume now is 48,261 centimeter cube. Okay, look at the shape again. So even if it is 3 cylinders or 4 cylinders, it might not be as big as this, but immediately you see it, you can find the circular part. And if it's 4 cylinders combined, because you might have a question like a pipe question where they have 4 cylinders combined, okay, which is underground and is giving sending water, so they can use that kind of wording to throw in a question. As long as you know the radius and you know the length, you should be able to find the area of one of them, multiply by how many cylinders there are, even if it is 8, okay, and then multiply by the length, and then that will be your volume. So they might even say that the volume of the water that is gushing out, okay, they might word it like that, but you should be able to see that it's a cylindrical question, okay, because most pipe lines are circular. So you can see that and solve the question. Okay, so again, don't be intimidated when you see figures like this, because you are just going to apply what you know. Okay, now let's look at our next example. Okay, now this is another example. Okay, this looks like they said we should find the volume and leave our answer to the nearest one decimal place. All the units are in meters. Okay, this looks like 2 right angle triangles, and it looks again like a prism. Okay, so it has 1, 2, 3, 4, 5 sides. But if I want to find this part and I just see it as M, I won't be able to figure it out. I can see this as a triangle and a triangle. They are similar triangles. Okay, so the area of this should be equal to the area of this. And then after I've found one area, then I multiply by the length which has been given here, 1.9 meters. All my units again are in meters. Okay, so I want the perpendicular, so the area of this triangle here, okay, is half base, and the height now here is what, 1.1 meters. So half base and height, so half, the base is 1.2. okay, this wasn't given. I've circled it because I wrote it there, because even though it's not to scale, by eye judgment, it looks like similar angles, and because they are right angles, it will be similar anyway. Okay, so I'm using that principle to say that this is also 1.2, but from what I can see it's 1.2, and the heights are the same. So this area of this right angle triangle will be the same as the area of this one. So if I can find the area of this triangle, I'll double it by 2 and then multiply by this, and that will be my volume. Okay, today we are only looking at volume of some of these shapes. Okay, because if they give you the volume of the cuboid, you can do it. A primary school person can do it. But it's just the same principle that you are using. Okay. So the area of the right angle triangle here, the first one, is half. The base is 1.2 meters. So 1.2 meters times the height, 1.1 meters. So if you do that correctly on the calculator, again, I keep on stressing the calculator because I assume you are using your scientific calculator, not the phone calculator. Okay. If you do that correctly, you should get 0.66 meters squared. Okay. They said we should leave our answer to 1 decimal place, but I haven't finished, so I'm going to keep this one for the time being. Now, if I multiply by 2, I have 1.32 meter squared. That will be the area of the 2 of this. Again, they might give you the area and the length, then they've made it easy for you. But assuming they haven't given you the area of these 2 bits, this side, and they want you to find the volume, you can still do it and get the marks. Okay, that is the shape here. Okay, so here, so you have that. So the 2 of the right angles is 1.232 meters squared. Now the volume of the shape, after finding the area of the 2 right angles, is the area of the 2 right angles times the length of the whole shape, which is been given as 1.9 here. Okay, so now 1.32 meters squared times 1.9 meters. When you multiply correctly again on your calculator, you have 2.508 meter cube. That is the volume. Okay. Now to the nearest 1 decimal place, you have 2.5 meter cube. So 2.5 meter cube to 1 decimal place is the volume of this shape. Okay, this is how a lot of engineers calculate stuff. Okay, and that's why maybe you can see some pipelines, the length, because they have used some of these calculations to do their work, to get things accurately and get them working. Okay, so now this is our answer here now. Okay, so as I've said to you, don't let the shape put you off from answering the question. Okay, because all we've done today, I haven't used any complex equation anywhere. All I've done is to work from what I know to the unknown. So I just apply what I already know. Okay. So use what you already know to solve the question. Okay, so don't look at the diagram and it's like, I didn't learn anything like this, so I'm not even going to attempt the question. Okay, this platform is about giving you tips to doing your Gcse and getting a good grade. So I'm trying as much as possible as I solve the question to show you how easy some of the questions, intimidating the questions might look, but actually you can solve them from what you know. Okay, so all you need to go in and sit down, clear your mind, and start reading the question, understand what they're asking you to do. Like today, all we did is to find the volume. But assuming you saw these figures in the exam, you might think, oh, I don't want to do this. This is too complex. You haven't even read the question. Okay, so take a deep breath. Read the question. Okay, even at home, if you are looking at a past paper, okay, don't say that I haven't, this is too complex, I'm not even going to attempt it, because the reason is, if they've brought it to your exams, they know you can do it. Okay, they've just added a little few bits to make it complex, like this picture here. Okay, like these two cylinders combined here, and like this three triangular prism together. Okay, but actually you know everything to solve the question. Okay, so thank you so much for watching today's video, and I'll see you in the next.